Hi everybody, and welcome to 24 Hours of Pass SQL Server 2014 edition. We're excited you can join us today. We have Luis Vargas' session, Always On in Microsoft SQL Server 2014. This event consists of 24 consecutive live webcasts, and the recordings of these sessions will be available at 24hoursofpass.com. My name is James Rowland Jones, and I'm a Pass Board Director, and I just have a couple of introductory slides before I hand over the reins to Luis. He's then going to speak for about 40 to 45 minutes, and then we're going to move through to Q&A, where you can ask any questions in the panel on the right, on the control panel. Luis, if you could just move us forward, please. So if you have any technical assistance during this session, please raise your hand by clicking on the hand button on the right-hand side, and someone will be on hand to help you. Okay. Also, if you need to, you can maximize your screen with the Zoom button and type any questions you have in the question panel down in the control panel area. Luis, again, thank you. We couldn't do this without our support of Microsoft, so a big thank you to them for their support. And also, just to bring you to your attention that the next SQL Pass Summit event 2014 is available now. You can contact your local chapter for a $150 registration discount, and the price at the moment is $15.95 until June 27th. So you can make the most of the discount and the price just before the bump. With this coupon. If you want any more information, feel free to go to www.passsummit.com. Now I'd like to introduce you to our speaker for this session, Luis Vargas. Okay, he's a program manager with the SQL Server High Availability team and has for the last couple of years been working on Always On, the new HADR solution from SQL Server team. Okay, he's also been involved in a number of other SQL Server areas in the distributed systems area. And with that, I'd like to hand you over to Luis, and I hope you enjoy the session. Thank you very much. Hi, Luis. I think you are. I think you might be on mute still. Can't actually hear you, so I think you might still be on mute.
Let me see. Can you hear me now? Hello?
Yes, we can, sir. Thank you. Yes, we.
What about now? Can you hear me? Hello?
Yes, we can hear you now, Luis.
Excellent. All right, so sorry for the issue there. So we're talking about mission critical availability. There are 4 dimensions that we want to ensure that SQL Server High Availability provides. We want a solution that is reliable. So the first thing that we wanted to look at since SQL 2012 with Always On is being able to detect any failures reliably. So we wanted to avoid false positives or false negatives in the system. So if there is a failure in SQL Server, if SQL Server is unable to reply to connections, for example, because the service is down or because it's continuously running out of memory, we want to detect those failures. We want to be able to support multiple failures. So if you have 2, 3, or 4 SQL servers, for example, in a configuration, and you have failures of one of the SQL servers or maybe 2 of the SQL servers, we want to still be able to have additional SQL servers that are able to continue running your databases. We want to have a solution that is integrated. So people who had a long history with SQL Server, they know that in the past we have different solutions for high availability or disaster recovery. So if you look at high availability, we had, for example, database mirroring, or we had SQL Server clusters. But if you wanted to also have disaster recovery, then you have to use potentially log shipping, or if you were using SQL clusters, then you will have remote database mirroring sessions. So before SQL 2012, there were still different solutions that you have to configure, manage, and monitor. Starting with AlwaysOn, we have a single solution that you can use for both high availability and disaster recovery. We want to ensure that we have a flexible solution, so we understand that many of you have existing investments, for example, in SANs. At the same time, many of our customers do not have SANs available. All they have is direct attached disks, and we want to be able to support still both environments. And finally, we understand that just keeping hardware in standby for secondary replicas, it can be expensive, especially because that hardware needs to match the hardware of the primary, so that in case that the primary goes down, the secondary replicas can take over. So we understand that those hardware resources are expensive. We want you to be able to use those hardware resources for something else than just waiting for a failover to happen. So those are 4 dimensions that we always keep in mind, and we kept those in mind when we introduced AlwaysOn back in SQL 2012. When we talk about AlwaysOn, AlwaysOn is really an umbrella term for a couple of technologies under it. So we have failover cluster instances. This is what traditionally you know as SQL clusters. These provide high availability for full SQL Server instances. We have had the solution in the past since SQL 2000, and every release we have improved over that. So very useful in consolidation scenarios. So if you have hundreds or thousands of databases that require failing over together, SQL clusters works pretty well for that. SQL clusters require shared storage, so all these servers that you have in the cluster require having access, for example, to a SAN or an SMB chair, and then we assume that the storage itself provides some level of redundancy, right? So we expect the storage to provide redundancy, so that in case that, for example, one of the copies of the databases goes down, there is an additional or more copies that the storage is maintaining. Failover can take between 30 seconds to a couple of minutes. How much? It depends on the amount of recovery that SQL Server needs to do after it restarts. So with SQL clusters, if we detect a failure, we start or restart the SQL Server service in a different physical machine, and all of those databases need to go to a recovery stage, right? So depending on the amount of workload, there is the amount of recovery. And basically every SQL Server instance that you have becomes a replica for one SQL cluster. So you cannot have a SQL Server instance that is a replica for multiple clusters. We introduced availability groups as a new solution in SQL 2012. It provides multi-database failover. This means if you have an application that depends on 2, 3, or more databases, you can put all of these databases in an availability group, and then SQL Server would ensure that all of these databases fail over together. It doesn't require shared storage, so availability groups can work based on direct attached storage. So if you have 2 or 3 SQL Server, for example, that you want to make part of the same availability group, one of them a primary and the other one secondaries, each of those servers can have their own direct attached disks, and then SQL Server takes care of synchronizing the log between the primary replica and all of those secondary replicas. So every time there is a transaction, at the same time as we write it into the local log for the primary replica, we send it over the network to each of the secondary replicas, and when those secondary replicas receive the log, they will store the log in their own direct attached storage and then apply the log to the databases, so that you have an identical copy, a physical copy of the database that you have on the primary replica. Because these secondary replicas are up to date with the primary, they are basically hot standby copies. All we have to do at failover time is stop accepting connections on the previous primary and start accepting connections on the new primary. So the process takes less than 30 seconds, Depending on how well architected the system is, this can go between 10 seconds to 30 seconds. Something else is that every SQL instance can host multiple replicas for more or one availability groups. So what this means is you can have subsets, for example, of databases, and you can put those databases into different availability groups, and then the same SQL Server instance can be acting as primary, for example, for some availability groups, and as secondary for other availability groups. So this allows you to amortize, for example, the cost of running active workloads on primary replicas across different SQL Server instances. And finally, these secondary replicas are active, so you can either do read workloads, so if you have reporting workloads, for example, or you have BI queries that you want to run, you can do this on the secondary replica. So you can offload all of that CPU utilization, memory utilization, and I/O into the secondaries. Same thing with backups, so you can offload backups from your primary into the secondary replicas. So there were a few enhancements in 2012 for SQL clusters. I'm probably just going to go quickly to this and focus more on 2014. So multi-site clusters support people who want to have clusters across different subnets. They can do that without having to stretch virtual LAN between the different data centers. So it's a lot easier now to set up clusters across data centers. You can have temp DB on local disk, so it's improved performance. It's faster storage, better utilization of the SAN. You can have indirect checkpoints. So we have a feature called, how do we call it? Remember exactly the name is, you can find it under indirect checkpoints in books online. Basically what this allows you to do is to specify how often to do checkpoints on the database. So by doing this more often, you reduce the recovery times after failover. So there's some interesting options for reducing RTO in case of a failover. And finally, we have something called flexible failover policy. So you can specify how sensitive SQL is to different types of failures. And depending on the level that you specify for failover, SQL will failover or not. So for example, the basic level 0 is the SQL Server service is down. So in that case, will cause a failover. But you can go higher levels, and for example, level 3 is SQL Server is unresponsive within some threshold, and the threshold by default is 20 seconds. You can configure the threshold, and if SQL is not able to reply back within that period of time, it will fail over. And you can go all the way to level 5, where we consider things like out-of-memory exceptions. So if SQL Server is running out of memory continuously, or we detect even some deadlocks, for example, that cannot be resolved, those will cause failovers to happen in the system. So all of this is documented in books online. You can specify how sensitive you want SQL Server to be to failures. Availability groups. So I'm probably not going to spend a lot of time here. We talked about this when we introduced it in SQL 2012. Basically, when we released it, we had support for 4 secondaries, 2 synchronous, and then the remaining asynchronous. It supports manual or automatic failover. Similar to clusters, it supports flexible failover policy. And there is this feature that some people know. I like to talk about it. I think it's a very, very interesting feature. It's called automatic page repair. And what it does is every time that a replica reads or writes a page in the disk, if we detect that that page is corrupted, because we have some checks on verification on the page, if that page is corrupted, then that replica will broadcast a request for that page to all of the other replicas in the system, and then those replicas will reply back with a healthy page. And then the original replica will replace the page with a healthy one. So basically this allows the system to be self-healing in terms of data corruptions. So it saves some headaches on the DBA. Couple of things that are interesting here. We have seamless application connectivity. We have something called a listener. So every availability group has a listener, and the listener is just a DNS name that all your applications can use to connect to your primary replica. So irrespective of how many replicas you have in the system, or whether these replicas are in the same data center or across data centers, you have a single connection point for all your databases. finally, sometimes customers ask, are every feature supported by availability groups? Yes, every feature is supported. So if you're using file stream or file table, service broker, contained databases, all of these features are supported in the context of availability groups. What that means is all of the data stored as part of those features is replicated to the secondaries, and in case of failover, that data is available and ready to be used. And finally, availability groups are efficient in the sense that you can use your secondaries, as I mentioned before, for read workloads, or you can use them for backups. And finally, failover is fast. We talk about between 10 and 30 seconds, depending on the system. If you haven't seen an availability group deployment, this is how a canonical deployment looks like. So on the right side, you have one data center and you have two servers, AlwaysOn server 2, AlwaysOn server 3. So these servers are configured as replicas for an availability group A, and the availability group has, in this case, one database. One of them is the primary, the one with the blue A. The other one is the secondary. And in most cases, the local replica in the same data center is used for high availability, and that means that you configure that replica as a synchronous replica. What that basically means is every time that the primary commits a transaction, it will wait to reply back to the client until the secondary has committed the transaction successfully. So the transaction is not considered committed until it has been stored successfully by the synchronous replica. And it's configured for automatic failover so that in case there is failure in the primary, it automatically fails over to the secondary. And then you can have additional secondary replicas. This could be in the same data center. This could be across different data centers. So in this case, for example, we have AlwaysOn server 4, which is in another data center which is close to the main data center. We have many customers doing things like this, and they use it, for example, for backup. So for compliance reasons, they need to be able to maintain backups outside of the main data center so that they can always do OOPS recovery, for example, to recover some tables that are deleted. And they want to be able to have those backups even in the case that the main data center becomes unavailable. You could have even further secondaries. So you could have, for example, another one in a far data center. In this case, it could be your disaster recovery site. And you could have AlwaysOn server 5. And you could configure this one as a synchronous replica. What this means is the primary will not wait for acknowledgments back from that secondary to commit a transaction. And this is good if you have high latency between the replicas. In general, we recommend people anything more than 20 milliseconds latency round trip, configure those secondaries as asynchronous to avoid impacting transaction latency in the primary. And then you could use that disaster recovery replica, for example, for reports if you want to. So if there's some parts of the organization that require doing some reports, you could run them from that replica. Right? All right, so we talked a little bit about 2012. We set up the context. Now let's talk about SQL Server in 2014 and what are the things that we have done. So we did things for availability groups, and we did a couple of things for SQL clusters. For availability groups, the first thing that we did is we have increased the number of secondaries. So very simple change. We'll talk about it, but the main thing is ensuring that we can do this without impacting the performance of the primary. We have increased the availability of readable secondaries. So we'll talk about what exactly that means and why it's important to some of our customers. I'll actually give you a couple of examples. And then we introduce a very interesting feature. It's called the Add Azure Replica Wizard. Basically, this allows you to create replicas in Microsoft Azure. So you can use these replicas either for disaster recovery or just to move some of your read workloads over there. So we'll talk about all of that. So we'll talk about exactly what cluster share volumes are and what can you do with them in SQL clusters. And finally, across the boards on both availability groups and SQL clusters, we have enhanced diagnostics. So diagnostics is one of those things that sometimes doesn't look like a very sexy feature, but at the same time, whenever there is a failure, you want to ensure that you have all the right information to troubleshoot the system as soon as possible. So we'll talk about some of the examples that we did in diagnostics as well. So let's talk about each of these improvements. Availability groups, first increasing the number of secondaries, right? So in SQL 2012, we introduced readable secondaries, right? This allows you to offload some of these read workloads. What we realized is it became a very popular feature across our customers. There are a couple of reasons why. So one of the reasons is with availability groups, you can have a single technology to configure and manage for both high availability as well as scaling out your reads. So in the past, for example, we have seen many customers using things like transactional replication for pushing copies of the data to multiple SQL servers and then reading out of those copies. So transactional replication has many strengths. It works very well, for example, to push data across different SQL servers that have different schemas. It works well to push specific subsets of the database, like specific tables, for example. It's great, for example, to allow indexes on each of these replicas. In terms of replication, we call them subscribers. So great, for example, to have different indexes and different workloads running there. However, there are a couple of things that you need to think about. One of the things is it's a different technology to configure and manage. So if you're using replication and you want to have also high availability, then you need to have two solutions, right? And you need to configure everything related to those solutions, like security, for example, and manage performance, etc. So many of our customers wanted to simplify that, and they wanted to use availability groups for pushing data into readable secondaries and reading from those. The other thing is pushing the data between these replicas is a lot faster using availability groups. So based on some performance testing that we have done, it's around 7 times faster. And the reason why it's that much faster, well, actually a few reasons. One is with availability groups, we have physical replication of the log. And what that means is we take every log block that is written into the primary replica, and we send it over the network to the secondary replicas. So we're basically just pushing the log instead of doing or redoing any of the operations that are done in the primary. So that's a process that is a lot faster. It's a continuous stream that we're sending over the network instead of, in the case of replication, which has some scheduling internally. And also we're using compression over the network, so it's around every log block that we send is around 40 to sometimes 50% smaller than how it is in the disk. So we're able to push as much as we can with availability groups, and because of these two reasons, we see many customers that are adding more and more readable secondaries into the system. And at some point, we got the request to add even more because they wanted to have, for example, additional offices within a geo-distributed environment, having local replicas so that they could read locally without having to go all the way to a different replica or even the primary. And the other reason is there are some customers that are scaling out some very intensive read workloads, and even 2 or 3 replicas were not enough for some of these customers. So they wanted to have additional replicas to scale out across them. So because of that, in 2014, we have increased the number from 4 secondaries into 8. So we doubled the number. If you ask why 8 and not 10 or 12, basically we talked to around 40 customers that have been using availability groups. We look at all of the scenarios. We look at what is the maximum number that they expect to need over the next 3 to 5 years, and we decided to close it on 8. We close it also because we need to test it, so we need to run all of our functional testing and performance testing, stress testing, etc. So we need to have a number that we can scope for testing. That's why we didn't want to leave it open to any number. We still allow only 2 synchronous secondaries, and this is basically for high availability. So you can have 2 synchronous secondaries that basically block the primary waiting for acknowledgments. So you can ensure that at least you have 2 copies that have exactly the same as the primary. We didn't want to allow more than 2 synchronous seconds just to protect customers from configuring 4 or 5 synchronous seconds and then impacting the transaction latency at the primary. So we had a lot of discussion on this, and then after talking to some customers, we thought that that was the best decision. What this means is you can have, besides your 2 synchronous seconds, up to 6 asynchronous seconds. And something to remember is the delay of these seconds. That means how soon these seconds will see the transactions on the primary will depend on a couple of things. It will depend on network latency, right? So we need to move this over the network. So depending on how much latency you have, it'll take that for the secondary to receive the log, and also on how much I/O you have available on the secondary replica. So if you have a fast disk on the secondary, then you will be able to apply the log quickly to those data pages. If the disk is slow or considerably slower than the primary, for example, then it may not be able to apply those changes to the data pages as soon as the primary, for example. Just giving you some rough numbers in terms of what we have seen, these 40-something customers. Normally it's less than 1 second within the same data center for these secondaries to have the same transactions as the primary, and it's around 5 seconds between data centers. So again, depending on latency and I/O, this may be less than that. Something that is important, you can add as many secondaries as you want in the system without impacting the performance on the primary. Again, this applies only to asynchronous secondaries. And the reason why we're able to do this is because first, commits do not wait for these asynchronous secondaries to reply back. Second, we have a single log pool. This is part in the SQL Server memory where we can store all the log that we read, right? So every time that we need to send these log records to one of the secondaries, we put it first in that log pool, and then we use that basically as a cache for the other secondaries. So all the other secondaries can read from that pool, provided that the secondaries are able to keep up with some time. Then all of them can read from the pool. If one of these secondaries, for example, falls significantly behind and is more than, let's say, 20 minutes and we don't have that information available in the log pool, then that secondary will need to read it from disk. But beyond that, all of the secondaries can benefit from this log pool. So just giving you some rough numbers, the added latency for your primary transactions after adding 8 asynchronous seconds is less than 1%. So it's a very, very good number. This gives you the confidence that you can go and put readable seconds, for example, in different parts of the organization, or you can start load balancing, for example, some of your read workloads across readable seconds without impacting the primary. Something to mention, as part of this release in SQL 14, we scope out load balancing as part of the connection string. So one of the requests that we had from customers is being able to just specify some load balancing option in the connection string so that we can load balance across all of the readable seconds. So unfortunately, we didn't have enough time to do that. So if you're using read-only connections, this means if in your connection string you specify read-only, we will still follow the same behavior as in SQL 2012, where we route you to the first available readable secondary in the system, right? So that basically provides high availability for your read workloads, where we always find the first secondary and send them there to ensure that your read workloads can continue running, but we do not load balance across the readable secondaries. It's still possible to load balance using things like DNS, for example. So that's generally what we see customers doing. So in the DNS server, you can create multiple entries with the same name and using the IPs of the readable secondaries, and then all your clients will be round-robin across the readable secondaries. Or some of our customers actually use more specialized load balancer solutions. This could be software-based solutions like network load balancers. This could be things, physical load balancers like F5 routers, for example. So depending on what is available to you, you could use for load balancing across readable secondaries. So something that we wanted to ensure is obviously do not change the current experience. So the current experience that we have in SQL 2012 is exactly the same one as we have in 14. You can add more secondaries. So in this screen, for example, you can look at the wizard for creating a new availability group, and you can see that we can have more than the 4 secondaries that we had in SQL 2012. Nothing changes. Very easy to go and change, for example, whether they are readable or not. And after that, the wizard will go and complete the full configuration for you exactly as before. So nothing has changed there. In Object Explorer, so if you look into the left side, you can see that it's exactly the same experience as before. You can have more replicas in the system. You can change the properties of all the replicas. Just right-click on the availability group, and then you can change their availability mode, whether they're readable, etc. So exactly the same as before. The dashboard is the same as before as well. So you can look at all the state of all the replicas. So you have a single place at the top, availability group state, and that will show you the health of the availability group. And that is a roll-up of the health of all the replicas. So you have all the information for all of these replicas, if they are synchronized or not with the primary, what was the last time that they committed a transaction, what was the last transaction sequence number. So this is the actual number of the transaction in the log. So you can actually compare, for example, how many transactions one of the secondaries is missing compared to the primary. So going into the next improvement, we have increased the availability for readable secondaries. So let me give you a little bit more detail. In SQL 2012, we had one scenario where read workloads could be killed during network failures. So, for example, if you have a geo-distributed environment where you have 2 data centers that are far from each other, and in some of these scenarios, what we have learned from some of our customers is failures and upgrades of network equipment are more common than we will want them to be. And what that means is every time there is a failure, for example, on your ISP, you may lose connectivity between the sites. And sometimes this can last from 10 minutes, 15 minutes, in a few cases up to 1 hour. So those are things that can happen today. And in SQL 12, we took the decision to, at that point in time, kill the connections from the readable secondary and then move the readable secondary into something called the resolving state. And the resolving state basically means the secondary doesn't know at that point who the primary is. So because of that, we took the determination to go into a safe state. We call it the resolving. So we have changed that behavior in SQL 2014. What that means is in 2014, read workloads will not be impacted during any network failures. So even if you lose connectivity between the readable secondary and any other data center, including the primary data center, the readable secondaries will still allow connections. Any ongoing read workloads will be allowed to continue. And basically, we changed the behavior for what it means to be in the resolving state. So replicas in the resolving state will still allow read workloads to continue and even new workloads to be started, but obviously they will not allow write workloads while that happens. Something to mention, this requires direct connections to the readable secondaries. So if you are using, for example, read-only routing, unfortunately read-only routing requires connecting to the primary replica. The primary replica maintains the list of all the readable secondaries in the availability group. That is the replica that routes the connections to the readable secondaries. So if the primary replica is unavailable, for example, because you lost connectivity to the data center, then this will not work. So for read workloads that want to continue at all times, irrespective of loss of connectivity to the primary data center, then we recommend customers to directly connect to the readable secondary server. And in most of the cases, this works well. In most of the cases, the read workloads are localized to a specific replica, and customers are okay running as part of that replica. So that should be fine for the large majority. Finally, the state of the replica as well as the last commit time for that replica are available both on DMBs in SQL as well as in the availability group dashboard. So this just illustrates the process. So if you lose connectivity between data centers, for example, your primary data center for some reason becomes unavailable, your other data centers will still be allowed to continue running any read workloads on your readable secondaries. So just talking about one of the examples here, you probably are familiar with Stack Overflow. This is a site where software professionals as well as IT professionals can go and ask questions about software development or IT management, and then other people in the industry can go and answer questions, and then basically that's the value of Stack Overflow, being able to find answers to the questions that you have. This is the topology that they have. They're very open about this, so if you just search for Stack Overflow blog, in their blog they always talk about their infrastructure and how they're using SQL Server, and including how they're using SQL Server 2014 and how they're using availability groups. So the main data center is in New York, in Manhattan. They have 2 replicas configured for automatic failover, and that's how they ensure high availability for the Stack Overflow side, including Stack Overflow careers. They have a new career site where people can upload curriculums, and then companies can offer jobs basically to people. And then on Oregon, they have the disaster recovery site, and that is configured as an asynchronous readable secondary. There is some more information about the configurations of the servers. They have 5 databases, and I think that's all we have to do here. But basically, their main motivation to upgrade to SQL 2014 was this increased availability of readable secondaries. So with Stack Overflow, 70% of the workload is reads, so it's mainly people searching for answers and reading the answers on the Stack Overflow side. So they wanted to be able to maintain that operations happening even in case that the primary goes down, and even in the case where the full main data center goes down. So for them, it's very easy to just change the DNS record, right? Instead of doing a failover, for example, to the disaster recovery side. The disaster recovery site, again, is running an asynchronous secondary, and what that means is at the point of a failure, it is possible that that disaster recovery site, which is in the opposite side of the US, may be losing some transactions, right, at that point in time. So they would like to avoid doing a forced failover to the disaster recovery site and losing some of those transactions. So they would like, for example, just to be able to change the DNS. And with SQL 14, that's exactly how they are. How they can handle the process. So they can just change the DNS and point to the readable secondary instead of doing a failover. So just a quote from Stack Overflow: the increased readable secondary availability means all users can still find answers online and the world keeps spinning. So this is just one example. If you look into Microsoft case studies and you search for availability groups, you'll look at other examples of how customers are using availability groups in SQL Server 2014. All right, so let's quickly show what we have been discussing. You should be able to see my screen. So what I have here is SQL Server 2014. So on the left side, I have my 2 replicas. So you can look at here, I have one replica called HADR0, and then I have another one called HADR1. So HADR0 is my primary replica. HADR1 is my synchronous secondary configured for automatic failover. This is for high availability. And then on the right side, I have HADR8, which is a readable secondary, right? I can create a table, insert some values. So on the primary, you can see on the left, I have inserted 3 values, and then I can read those values on the secondary, right? At some point, I can stop the SQL Server service on the primary. So I'm going to stop it. Once the SQL Server service is stopped, you can see that there is a failover that happens here, and then my new primary comes online. Right? At that point, I can still read from my readable secondary. So that is still the previous behavior that we had in SQL 2012. That is nothing new. So at this point, I can insert a couple new records on the primary, 4 and 5, and then I can read those on the secondary. So all of this is still previous behavior. Now the new behavior is the following. So we can stop the new primary. So I'm going to stop HDR1, right? And when I stop the primary, right, you see that at this point I don't have any primary available in the system, right? So I don't have a primary. If I try to insert any values, I'll get an error basically saying that the primary is unavailable. But on the readable secondary, I can still continue reading from my database, right? So this is a new behavior. Even if you don't have access to your primary, the full data center is down, you can continue reading. If you look into the dashboard in SQL Server, will notify you that there is a problem, right? So obviously, we want you to be aware that there is not a primary available at this point in time, and that the secondary is not synchronizing with the primary. And this is because the primary is unavailable. So we'll actually show you here that the secondary cannot connect to the primary. And we'll provide you a couple more information. So we tell you, for example, what was the last sequence number, the last transaction that this readable secondary committed, and when was the last time that this readable secondary committed the transaction. So you can always compare that with what we have on the primary. At some point, when the primary comes back online, right, the readable secondary will automatically detect that because it continuously tries to reconnect to it. It will reconnect to it, and it will automatically update the dashboard, showing you that it's synchronizing, and then the last commit sequence number and time have been updated. So that's basically the demo for that. I'm running a little bit behind time, so let me go into the one of the final improvements. So this is adding the option of having replicas in Microsoft Azure. So we know that many customers today can't afford a disaster recovery site. It is expensive. You have to pay rent for the site, maintenance. You need to have some hardware. You need to have some operations people running the site. So around a year ago, we started supporting, since SQL 2012, adding replicas in Windows Azure virtual machines. Right? So what this allows you to do is have SQL servers that are running in Windows Azure virtual machines as part of the Microsoft Cloud, and these SQL servers continuously synchronize transactions from your primary replica, so that if your primary replica becomes unavailable, you can fail over to one of these SQL servers in Windows Azure. You can put these servers in any of the regions supported by Windows Azure. We have in US, Europe, Asia, and we're always adding new regions. We just had a new region coming in Brazil, and I know there are plans for additional regions. You can specify where to put the replica. This is how it looks like. So in your main data center, you likely have one secondary just for automatic failover purposes, for high availability, and you can have an additional one in Windows Azure for disaster recovery purposes. Having this secondary is low cost, is significantly lower cost than having a disaster recovery site. All you have to pay for is the cost of having the virtual machine running, and there is some cost associated with the storage. So depending on how much storage you have on the size of your database, there is some cost. All the traffic that you send into that replica is free. Right, so you can push as many transactions as you want, and all the traffic is free. If you're interested to learn about how some customers are already using them today, you can go again to Microsoft case studies. You can either search for availability groups or just search specifically for some of these customers who are using them today. Right, so some examples. In SQL 2014, something that we introduced as part of SQL Management Studio is a new wizard. It's called the Add Azure Replica Wizard, and this will allow you to provision a new virtual machine which has SQL Server installed already, and then add that virtual machine to your on-premise cluster, and then take a backup of your database, restore it into that virtual machine in the cloud, and then start synchronizing transactions automatically for you. So it takes care of end-to-end for all the end-to-end workflow for you. And it will do a few more things like validate your environment, handle some failures, and do some cleanup if it's required. This wizard applies to SQL 2012 as well, so feel free to go and download, for example, SQL Server 2014 Express editions with tools, and as part of that, you'll get the wizard, and you can apply that to your existing 2012 if you want to. I think I'm running a little bit behind on time. So let me quickly show just one walkthrough for the wizard so that you get an idea of what the wizard does. So we have again SQL 2014 on Object Explorer. If I right-click on the availability group, I can select Add Replica. This brings the traditional Add Replica wizard that we have today, except that we have added a new button here. So you can still add replicas on-premise as you do it today, but we have added this button, Add Azure Replica, and this will allow you to add this replica in Windows Azure. So if you click on the button, this will bring this screen where you can specify some certificate and some subscription in Azure to manage. If you don't have a certificate yet or you don't know your subscription, you can click on download, and this will bring the same screen that we have in the Windows Azure portal, where you can sign in with some Live ID account, and then we'll automatically download a certificate for you. We'll install it as part of the local certificates in the machine, and then you can use it to manage any subscriptions in Windows Azure. And after that, we'll download some information from Windows Azure about what are the types of, we call it images. These are basically templates that you can have for your virtual machines. So we have templates, for example, for SQL Server 2012 or 2014. You can select the one that you want. We have different versions of Windows as well. And you can select the size of the virtual machine. This can be large, for example. This has 4 cores and 8 gigabytes of memory, or it can be smaller or larger than that. Finally, you can specify things like what is the region where you want that replica. So in this case, for example, I can specify I want it in Central US, but this could be West Europe or Southeast Asia, etc. And once you specify that, basically this replica becomes one more in the list of replicas in the system. You can make it readable if you want, and then you can specify how to move the data into Windows Azure. So by default, we take a full backup of your database, and then we restore it in that machine. And we go through different checks, and at the end, we'll basically execute the wizard, and you will have a SQL Server running in Windows Azure with a replica of your databases. So it's a very interesting feature to look at. Let me go back into the presentation. I think I have only 10 minutes, so a couple of quick things that I wanted to mention before we jump into questions. I won't talk about enhanced diagnostics, so just let you know there are 24 enhancements that we have done all across SQL Server on dashboards, DMBs, error messages, just to make it even easier to go and understand things like why the secondary is not synchronizing, or why some failover happened, or why some failover didn't happen, what was the reason behind it. So there is more information that you can look at. So I'm not going to go into detail here. If you go into books online, we have some more detail about these diagnostics. I wanted to talk about SQL cluster instances. So for some of you who are using SQL clusters, we have introduced support for Windows Cluster Share Volumes. A cluster share volume is a new technology in Windows. It started in Windows 2012. And what this allows you to do is have a single logical shared disk that is accessible to all the cluster nodes, and this logical disk is accessible over the SMB protocol. And one of the very good things about this is that you can have one or more of these shared disks within the same physical drive. So if today you're using your physical drives, you know that you're restricted to the letters of the alphabet. You probably can't use a couple of those drives. Maybe you don't use C because that's for the operating system. Maybe you don't use D because that's for some removable media, like a DVD drive, for example. So you only have the remaining letters left. So if you have some SQL clusters, for example, that you want to install in your shared storage, you already have a limited number of drives. So with cluster share volumes, now you can have as many cluster share volumes as you want on top of the physical storage, and then you can use those shared volumes to store the data for your SQL clusters. So this basically improves the utilization of your shared storage, especially if it's an expensive SAN. It's very interesting. It increases resiliency of I/O. So every read or write that goes into shared storage through the cluster share volume will be retried through different cluster nodes if the initial one fails. So if, for example, you have one read or write that is going to the shared storage through the link from one of the nodes, and that link becomes unavailable, the cluster share volumes will automatically retry that through a different link. So it increases resiliency. All of this is transparent to SQL, so it's an important resiliency feature. Finally, it increases resiliency and failover time. So in the past, if you were using traditional drives, when SQL cluster fails over to a different machine, we have to unmount and mount the drives on the storage for that machine. With cluster share volumes, you don't need to do that. The new primary, all they have to do is connect to the cluster share volumes over SMB without having to mount and mount. So there is less opportunity for anything to fail in the system. So this is how it looks like. So on the top you have the Windows Failover Cluster Manager. So in the Windows cluster, you can define the cluster disks, right? And now some of these can become cluster share volumes. You see here we have, for example, cluster disk 1 and 4, which are cluster share volumes. And then when you install the SQL cluster, you can refer to those cluster disks, right, when you declare the disk that you will use to store your data and log files. So very transparent to SQL and additional resiliency and flexibility. So we're running out of time at this point. I'm not going to talk about some of these things. Let's open to questions.
Okay, great. Well, first of all, thank you very much, Luis, for that great session. Let's just start at the beginning. You mentioned that automatic page repair was something that you liked, and that's our first question from Marianne. She says, regarding automating page repair, is there an error or warning message saved in the SQL log for this corrupted page? I.e., how do you know that this has happened?
Yes, so there is both a log message in the SQL error log. I'm trying to remember the specific error. I think that we say data page, and then we give the ID of the page, and then corrupted. So if you just search for that string, data page corrupted, you can go into Books Online, just search for automatic page repair, and we'll give you all the information that we expose. This is also exposed on DMBs. So we have, I'm trying to remember exactly the name of the DMB. I think it's auto page repair, I think is the name of the DMB, DM_auto page repair. And I will also give you information about the last pages that have been automatically replaced in the system. Okay,
that's great. Thank you. The next question comes from Balaji, and he says, is the synchronous replica function a read-only replica? So is that just for read-only?
So you can have readable secondaries using synchronous or asynchronous secondaries, so both can be readable.
Okay, that's great. And then Siva asked a question, is the drive letter and size, just lost, just went off the page. Is the drive letter and size, does that need to be the same on the primary and the replica servers for AlwaysOn? So basically, does my disk configuration have to be the same on the primary and all the secondaries as well?
So they don't have to. It is highly recommended that they are using the same letters. The reason why is if they're not using the same letters and eventually you do some file operation, for example, you try to add a new file into a file group, when we try to redo, when we try to apply that operation in the secondary replica, that will fail if it's not using the same letter. So, I mean, there is obviously, you can manually go and redo the operation, and you can, you know, handle the operation yourself, but we really highly recommend to use the same letters on both.
Okay.
It's one of the best practices that we have.
Okay, that's great. Thank you. And then Nick, who saw something quite familiar in his in your presentation today, he says, is there any way for each data center to have a read-only listener even when the primary is in another data center, i.e. without needing to contact the primary, basically a listener that points to one of the read-only replicas in a local group, say in the same subnet?
Got it. Hi, Nick. First. So not today, unfortunately. So today we don't have that concept of listeners scope to specific subnets. The listener is just a single point of contact across, you know, the full deployment. That's something that we're looking for the next release. There are different enhancements related to load balancing, for example, and how to contact the readable secondaries. But for now, the only possibility is to connect directly to the readable secondaries.
Okay, that's great, and yeah, I mean, maybe that's something that you want to kind of advocate on Connect, Nick, to give the team greater visibility on the priority of that feature. So Joe Smith, he asked, do we still have to manage agent jobs manually between primary and secondaries like we had in SQL 2012?
Yes, so unfortunately that's something that still you need to do. If you have agent jobs, you need to copy them locally on both at some point, and you need to have some logic in the agent job that exits the job if it's not the primary, because most likely you only want to execute the job on the primary. That's something that we're looking into the next release again. For people who are familiar with contained databases, in SQL 2012, we started going through that path of enclosing, you know, or pushing some of these instance level objects into the database. So in SQL 2012, we contain logins, for example. So now you can have logins that are part of the database that do not have dependencies on instance level logins. And we're looking now into agent jobs. So again, unfortunately, SQL 2014, we didn't have time for that. It's something that we're looking for the next version.
Okay, we've got just a couple more. There's a little bit of question marks around the Windows mount points. He's just asking around are they supported or not versus drive letters. A lot of conversation about drive letters, so people just want to know whether or not those are supported.
Yeah, so mount points are supported for both SQL clusters and availability groups. In the case of SQL clusters, we recommend now to use cluster share volumes, just because it simplifies the full management of the drives.
Okay, perfect. And so that kind of answers Mark Broadbent's question, a regional mentor from the UK, saying CSVs are the best thing since sliced bread. True or false? We'll go with true, and we'll call that a day. Thank you, everyone, for your time. Obviously this will be up and available. The recorded session will be available a week from now. Thank you to Luis for that excellent session, and thank you all for attending. I hope you enjoy the rest of your 24 hours of pass. Thank you very much, and bye for now. Vicky, you can close this one out.
Thank you.